and we're relatively earlier in the week, so hopefully we haven't heard this song and dance too many times. I'm Justin Bork. I am the MC for this. I'm just going to give you a few housekeeping items at the beginning and at the end. And we're going to have our presenter, Ellis Wong, do the majority of the work here. But before we begin, I want to give a shout out to Suffolk University. Suffolk University is hosting this. They make this possible both this year and last year. And this space, keep in mind, I mean, this is right in the center of everything. So it's just an amazing opportunity to benefit from the resources that Suffolk University has and to just be where the action is. So really glad to have you guys here. Look around. You'll see a bunch of people wearing Boston Celtics colored Startup Boston jerseys. This is an all volunteer event. It's a labor of love. It's how we're able to make this free for everybody. We're here to help you. So you'll see a bunch of other volunteers over here. Everybody working this event this week, we're all volunteers. Give your volunteer a hug, a high five, and don't be afraid to ask us questions. We're here to help you get to where you need and make sure you get the most out of this event. So with that said, we're going to pass it over to Ellis here and take it away.
All right. Thank you, Justin. Hello, everyone. Good morning. Can everyone in the back hear me, by the way? Yeah. Okay. So I want to make sure I have a little bit of cold, so a little bit congested. So first of all, this session is going to be covering the startup scaling ideas. I want to make this a learning opportunity, so it'll be actually more of a dialogue rather than me pitching to you. And since it's an engineering track, the focus will be more on the technical aspect of scaling, essentially technology, especially for technology leadership in startups. And so we'll cover some of the best practices and so forth, and also cover some use case. So I will, when Startup Boston Week asked me to present, asked me to come up with some ideas to talk about scaling startups, I'm very excited about this topic. So I actually have too much material, so I'll probably skip a few of these. Otherwise, we'll be here for 2 hours. So a little bit about myself. For over 25 years of my career, I've been fortunate to be working in actually fast growth startups, from being essentially one of the early engineers for Wealthy Communications, for example, and built eventually saw the company grew to thousands of people and eventually acquired by Nortel. Also been in a founding team member as well as early a member of the leadership team in leading the growth of a couple of startups from conception through eventual successful acquisition exits. In addition to that, I also have experience in scaling engineering organizations in Fortune 500 companies, and with most recently with American Family Insurance, where I had an organization of over 150. So so I basically bring a balance of both startup and enterprise experience in scaling organizations. And so I have, in addition to that, a extensive cybersecurity background as well. So I will be injecting some of the cybersecurity perspectives into the scaling effort. My core expertise is really in the high performance real-time processing architectures, along with big data, cloud, and web services organization platforms. So with that said, basically with today's competitive environment, I really believe that it's much easier to start, especially with the advent of AI powered tools and so forth. So it's really impending the actual advances of AI to allow for startup leaders to basically take advantage of that, but be able to apply more strategic strategies to scale their operations and company. So we covered some of the best practices that I personally employ and some of the experience in a case study myself. So we'll cover basically just the startup phase of the company, where within the life cycle of the overall business life cycle. So we got simply just the initial early stages of company, so to speak. So this is a textbook definition of startup. So the key milestones that we'll find in And the startup here is that during the seed stage, we're all trying to figure out what the product is to address, or more importantly, actually, the unserved or underserved needs of the target customers, and be able to find solutions to address them. Once we actually get to that initial so-called prototype to demonstrate the actual concept of your solution, then you can basically get the growth of your company to get to product, at least a product market fit, having enough of the user base to validate your solution. And that's when you actually can get to that Series A round of funding, where you can truly get to full true market and product market fit. And then from there, you can basically expect to execute further and scale the business. And once you get to that road to profitability, that's when you can reach that hyper growth stage, and where you can certainly raise additional capital to scale further, to expand internationally, or aim for an initial public offering, or an acquisition. Let's exit at that point. So when we actually talk about scaling startups, we really have to focus on really 4 pillars of what makes essentially an operation of a startup company. So it's about people, strategy, or process, technology, and tools. So in the startup, in the seed stage of a company, this is where you have an initial founding team that are fully aligned within the overall mission and vision of the company. And at this point, it's all about, the strategy is about testing and learning from your early adopters, be able to iterate quickly. And the technology that we typically use, at least in my experience, is really a lot more of the wireframing, leveraging now a lot of the no-code, low-code platforms, such as Bubble, I love Bubble, or Figma, to really build out some concepts, be able to validate, test, and learn, iterate over that, and perhaps pivot at this stage, as there'll be lots of pivots during this stage. So as you get to actually some more of the market traction, then you basically be able to focus on building out a strong foundation of culture in the company. This is when you actually optimize the talent to the overall, now start basically building out the platform where you can migrate from the initial monolithic implementation of your technology into microservices architecture, be able to scale, start thinking about automation, and then basically implement some of the feature flags as a way to test and validate your user feedback for new features that you introduce, and to add additional value proposition to your customers. So this focus in this stage is all about get to that product market fit, right? And this is where nowadays you can leverage lots of automation and AI-driven tools. Aptical is one that I use to actually screen candidates by actually having essentially a offline, asynchronous manner testing about validation of their skills, but both actually technical and cultural fit. By the way, you can actually use probably a forms-based type of template to basically fill out some initial questions. 15 to 20 minutes a session, where the recording will be sent to essentially the hiring team, and be able to evaluate the candidates and narrow down your search pool. And moving on to the next stage, growth stage, is where we start scaling out other functional areas. You basically scale up your sales and marketing teams, where you start basically establishing cost centers to manage costs more effectively. they'll be able to scale your recruitment further. This is where you actually can start thinking about making sure that you start developing your talent, retaining your talent, building your leaders to scale up your organization structurally. And more importantly, this is when you need to maintain or establish cross-functional or essentially objective key KPIs. So basically, the OKRs allow for alignment of the company's functions to a common set of objectives. So, and then there are lots of technology considerations here, especially now you probably have scaled your platform to essentially a more hybrid multi-cloud environment where you have to start thinking about performance and cost optimization, that normalization of your platform, so to speak. And then from a tooling standpoint, this is when you will be leveraging a lot more of that business architecture planning along with your product portfolio planning to establish essentially an enterprise or the company-wide roadmap. This is where I personally invest a lot of effort in building out and executing disaster recovery plans where it provides actually the benefit of not only be able to meet compliance and regulatory compliance, but also to actually test the resiliency of your overall infrastructure, right? So that's a very really critical step in not only security, but also the resiliency of your operations. So I'm going to be just diving into more of that, the architecture concepts for scaling. A lot of this is basically well proven. So microservices really allows us to break the applications into smaller, much more loosely coupled, independently deployable components, and adding to the scalability and flexibility of that platform. A serverless architecture allows us to focus on scaling cost effectively, especially in the sessions where you will have in actually features and capabilities that have quite spiky type of performance, which I cover that a little bit more in detail. And then containerization is when you are to ensure the componentization of the features and capabilities that can scale and be able to have the consistent configuration across different environments. So adding to the isolation and further scalability and resiliency of your platforms. A lot of the platforms now, especially supporting e-commerce or in case of the use case I cover later about high frequency trading, it's about basically event-driven processing. So there's a lot of techniques that are so-called event-driven architecture, especially based on CUDA or other containerized infrastructures. And then the distributed computing is when we can leverage the distribution of workloads amongst the different so-called working nodes to allow for not only the sharding of division of the actual work and data amongst different processing units, but also the resiliency and processing efficiency of very large volumes and processing loads. And finally, when we actually get to some of the really high frequency real-time processing is when we employ a lot more of the in-memory computation, hardware acceleration techniques. So I'm going to skip the slide since it's going to be has already touched on a lot of very common concepts. Instead, I will basically dive a little further into a favorite subject of mine, which is the continuous integration, continuous deployment. It is a well-proven operational practice that brings a lot of value. Basically, allow for the true collaboration between development and operations teams, where we can actually enable faster releases by automating a lot of the procedures in the workflow, all right, to be able to automate the actual testing for both quality and security vulnerabilities at the same time. And we can leverage the so-called codification capability of these in the pipeline to ensure that consistent configuration change control are managed throughout the life cycle of your operations. And then as mentioned earlier, the ability to ingest or integrate so-called the scanning tools for security vulnerabilities really improves the quality and security capability, protection capability of your application. So next is what I would refer to as the so-called GitOps practices. So GitOps really is a subset of CI/CD, where it's a modern approach to managing infrastructure in a codified manner. So it's basically a practice that ensures consistent, repeatable management of infrastructure and applications to minimize your human errors, and the fact that it has the declarative nature of the setup allows for any change to be tracked and allowing for review amongst the development team. So basically, maintaining that transparency and accountability, especially for audit purposes. So, and again, it's as a codified function of the workflow. You can actually simplify the actual process to have real granular control. We can roll back on a feature by feature basis as needed. So there's actually one example that I want to cover is a recent. I'll get to that in a minute. So another advantage of the essentially GitOps is the integration of overall policy management's policies to your actual operations. So oftentimes a lot of the security policies are defined, but they're not really enforced unless you actually have the real instrument them into your actual development environment or operations. The way to do that is basically leverage, for example, a cloud-based policy management system to be able to scan your basically your IAC template, for example, your Terraform templates, and be able to detect any skew or risk in actual configuration changes. And then with that type of scanning, now you actually can cross-check each other. If there's actually a policy change, you can actually update that the actual code, that's the actual IAC template as well. In addition to that, you can also make sure that you can inject the scanning tools within your CI/CD pipeline as well to ensure security is always be part of that overall quality aspect of your system. So one of the areas that I am very excited about is actually the advent of these so-called new internal developer portals from solutions such as backstage or ops level, where they integrate the overall, not only the development environment, so IDE, along with the GitOps workflow to kick off your builds, and then the actual, eventually, also the scanning of your security vulnerabilities, all within an environment, integrated environment. So now you can actually create a standardized set of workflows for each new member of your team. So it simplifies the onboarding process, but also allows for consistent best practices for your team throughout the development, software development lifecycle. So one of the areas that I basically wanted to touch on is the preview environments that we actually integrated the GitOps capability of a preview environments into our so-called IDP to enable feature by feature verification. So how do we actually, what's, first of all, preview environment? It is essentially a capability that's introduced in the Git-based essentially source control systems. GitHub is a prime example where they enable the developer to actually create a feature branch, which then basically allows us to set up a configuration with the part of the GitHub Actions to launch it's actually a fully functional working environment with the application working as if it's in a live environment, and be able to allow for the feature to be tested both from so that we can iron out the bugs and performance issues before we actually merge them into main. And this is actually a powerful way to scale your development effort. You actually allow for true collaboration within your team, as you can actually set up your preview environment and provide the actual, in fact, URL to basically allow for your team members who are actually involved in reviewing your pull requests to actually test out your changes before you actually commit that change to main. So we have employed that extensively for the last quite a few months in our software development team. So it's easy to set up, and we basically set up the configuration based on the full containerized Kubernetes environment, the same configuration that we would for as in a live application. So it will deploy the actual build files, any of the static files into static storage such as S3, and be able to provide a preview running application in as part of the pull request review process. So another strategy and approach in actually scaling your platform is really to leverage the power of feature flags. What we have put in practice, especially in American Family, is the ability to gradually roll out features, be able to test them in a large-scale basis by introducing this flexible control within our platform, both the front end and back end. It allows us to, for example, launch a new experience on a UI that is, has the corresponding change in the back end in tandem, and be able to test out basically 50% of our traffic, e-commerce traffic, on one implementation versus another, and be able to roll that out and find the most effective version, and be able to then commit to that full version, that winning version as the as into production. So it is it's a very flexible fine-grained control that we can employ using tools such as Optimizely or Hotjar. Optimizely is the platform that we use for feature flag testing. So moving on to subject that we probably very familiar with these days, the AI assistance in our development environment. So we basically have now a plethora of AI tools for code, basically assisting our coding development. So GitHub Copilot, Code Whisperer from AWS, or even a basically a prompt-based using natural language processing tool for generating code called Cursor AI. In fact, there's a video online of a 9-year-old girl who actually coded up an application just by using her prompts. So it's a very interesting video if you have a chance to look that up. So now this basically changes the game in such that we can stop thinking about how we shift the way our teams work, especially if you want to establish or maintain that type of pairwise programming model for your team. Now you can actually leverage a co-pilot with one of the team members instead of actually dedicating two to work on a feature. So it's certainly a powerful way to scale your product development timelines, but I want to actually point out some cautions through personal experience. So I find that if you actually have used basically any statically typed languages, for example, C, C++, or Java, is where it's actually best fit for use of these AI code generators, simply because of the fact that you can you need to compile the code, these statically typed programmed language code into machine code, and during that compile process, you can catch errors. And whereas if you use basically dynamic languages such as Python or JavaScript, basically the AI tools today simply do not have the full context of essentially the functional model of your application. So oftentimes they introduce errors that we basically catch as it doesn't integrate or doesn't actually function as intended in the actual either process flow or in your design. So one other area that I keep catching my team on is the fact they use AI tools to generate tests to test the AI generated code itself. So that's certainly a concern, because you certainly don't want to actually have the self-fulfilling process here, where the AI generated test to essentially affirm its assumptions, its own assumptions. So basically, make sure the team doesn't basically develop the test essentially ourselves instead of relying on the AI tools to do so. So again, just a couple of cautions to point out for the use of AI tools, but certainly a powerful way to scale up your organization that way. And the next is really I wanted to touch on is, besides the technology and tools, it's obviously the scaling of your talent as well. The way that we now in the age of AI, do we really need to find the most prolific programmer out there? I always believe in actually best engineers, actually those actually have a very wide array of functional experiences and skills with strong critical thinking and problem solving capabilities, right? So this is where we have to define perhaps a bit more refined criteria of skills for your team. As we scale the team, especially through that hyper growth stage, I basically went through a stage where I scaled the team from 60 to well over 150 in 2 years, where we actually have to templatize, automate a lot of the hiring process and the workflows. So the way that we can use these AI tools, as I mentioned earlier, Aptical is a wonderful tool to use, where you can actually have the upfront assessment, and then narrow down your candidate pool for further evaluation. And as a startup, you still actually have to fight for talent, and the way to do so is really branding your startup as effectively as possible, ensuring that the team has the candidates you search for really buy into your vision and mission. So a lot of we still, as a small company, has the agility to move a lot faster than a traditional corporate enterprise. So take advantage of that. Another suggestion is to standardize all the operating procedures as well as inventory for your team. This is where you gain efficiency by having not only that standardized workflow for onboarding your team members, but also a set of hardware and configurations that you can allow for the team member to come up to speed as quickly as possible. And so, and then as a security officer, I always basically emphasize on investment in both security and compliance as a foundation. So it's a tricky balance that we have to make, but the investment in security early on, especially if you can dedicate a good portion of your roadmap priorities towards addressing security vulnerabilities, pays a long way, especially when now expectations for marketplaces, you have to be able to certify the compliance to ISO standards or SOC 2 standards for any platform company that's ready to work with customer data. Right? So let's go to some of the more exciting stuff. So how we're doing on time, by the way. Is that good? Okay. So I'm currently with a high frequency trading platform company. So the basic, just dive into the actual scaling efforts that personally have worked with. I want to at least just give a high level overview of what high frequency trading platform is. Keep in mind, this is a very high level view, and obviously it's much more complicated than this one. That's what's depicted here. So at its core, a high frequency trading system essentially takes in market data that drives the algorithm engine that basically implements a lot of the trading strategies, and then derives a particular order to either bid or sell, basically push that to order router, then be able to then place that order out to a market or another exchange. So the name of the game is speed. It's I think of F1 racing is really a good analogy, because if you're late for a bid or an order, you basically would either lose money or be out of the game. So the key requirements for a high frequency platform is low latency. We're talking about 5 to 20 microsecond scale, right? So that is from ingress to egress on an individual node. So that with perhaps roughly about 100 microseconds as a round trip time for the in addition to the low latency, you basically have to make sure that the platform can perform and scale consistently, even as the traffic pattern increases. So we expect the platform to perform just as capably, be able to manage process all the orders and place them into marketplace at 10,000 messages per second, as is 100,000. So the analogy I like to use is basically a credit card charging machine at the checkout counter. You expect it to work just as fast in any ordinary Sunday as in Super Bowl Sunday. So another key requirement for a high frequency platform is the high reliability. We want to make sure that we are able to handle every single message that comes in. That means every process and it has to survive through essentially very rigorous processing speeds. So this is essentially a prime example of essentially parallel processing, and this distributed processing nature really is very appropriate for microservices-based architecture. So a lot of the actual high-frequency platform implementation is actually based on farms of bots. The reason that we implement these algorithms in bots is because the sheer speed, scalability, redundancy, and reliability that's needed for the platform, and especially for digital asset trading, no human can be able to maintain the 24/7 market monitoring and trading performance. So therefore, farms of bots are implemented in the microservices-based architecture in the high-frequency trading platforms. So in order to get to the scaling of the performance of the high-frequency HFT platforms, we basically have to consider what programming languages do we have to use. So there, at least in many of the high-frequency trading companies, seeing they're basically leverage both hybrid, both real-time processing-based languages such as C, C++, or Rust is another popular language of choice, and also Python. Python basically allows for not only the easier adoption and onboarding of new team members, but also can leverage the integration with a lot of the machine learning data analysis packages out there. So it is certainly a strategic benefit to use Python as part of your platform implementation for high frequency trading, especially for those higher level business logic implementations. So I'm going to skip this one. We've actually evaluated several approaches to optimize our programming, our source code to make sure that it can run as quickly as possible. So PyPy is a popular choice for a lot of the companies, but we actually went from PyPy to actually Nutka, which is actually essentially what is referred to as advanced so-called ahead of time compiler. So think of essentially statically typed language such as C or C++. You basically compile that from a command statements to machine code. Basically, Notecode takes that same approach. We basically compile the Python code down to machine code and be able to turn that basically compile that into a Linux compatible executable that you can actually now deploy in essentially a microservice based architecture. So benefit for note card basically allows for much higher speed up, especially the initial speed up of your process. As in any dynamic languages based programming, there's actually a penalty in launching your application up front, and that penalty, that delay penalty, really is uh, a, adds a lot of latency within a high frequency trading platform. So having that Python code compiled down to a machine code allows for that in the actual executable to be able to run without the penalty up front. So it's easier for distribution without having to ensure that every environment that runs the application have to install the Python environment. You can actually, as the code is compiled onto actual executable, you can actually distribute that to any of the containerized or Kubernetes-based environment. It's actually also much more efficient in terms of memory usage and CPU usage as well. So Nutka is also compatible with Python 2 and Python 3. So there's we basically had some pretty strong, excited about the findings from the use of Nutka, where we improve our overall CPU performance by over 67%. So another area that we actually focus on in terms of scalability is data management infrastructure. So for at the start, when we actually built out this platform, we employ more or less a standard data management architecture where it's based on essentially a data lake at the I don't have the pointer here, but you see the data stores. Really, it's implemented as a data lake or some sort of Kappa architecture, basically. And that the actual functions, the compute functions are employed by the bots basically have to pull data from the data lake on a very frequent basis. As you can see, that's not a scalable approach. So, and basically the data delay in pulling data from the data lake, it really increases the whole, makes the actual algorithms to be even more complex, as we actually have to employ much more complex queries to make sure we can actually get the data set that we need. So that larger and more frequent queries causes that data gravity issue to continue to scale. So essentially allows for a really essentially not a reliable system. More importantly, it's the actual state of the application basically spans between now the actual bot as well as the data layer. Right. So what we did was actually we actually migrate from a pull-based approach to a push-based approach. So the way that we employ this change is to basically, instead of pushing data out, allowing every bot to pull data from the store, we basically build out actually a set of so-called point-in-time derived refined subsets of data, where only the bots that need that particular subset of data subscribe to it and be able to actually get the data pushed to that bot at the right time. And so therefore, we basically allow for not only the refinement and the performance, but also the amount of memory storage and necessary at each of the functional components. So we have now able to be able to store much smaller amount of essentially refined data in the cache memory, not co-located within the actual compute engine and then now with that co-location, we can actually think about scaling the systems more reliably as state is maintained within that system component. So this really introduces a much more effective scaling of our platform. Be able to allow us to scale to onboard new exchanges, be able to handle a lot more of our trading. Actually, for example, split up our bots to dedicate the trading on index by exchanges, for example.
A quick question, if I may.
Sure.
What would be increase in speed?
So basically, we're looking at basically 100K messages per second for market data you're talking about. So I'm not sure how much time we have, but I do want to. How much?
15.
15. Okay, good. Certainly. So actually, another interesting technology and a platform that I actually starting to evaluate, and I want to bring this up. It's perhaps to basically share with everyone. Hopefully, we can if anyone has experience with the scalable spot scaler solution, essentially from a Visa. So they basically introduce a concept of AI-driven model to scale the Kubernetes event-driven architecture. So allows for essentially the workloads to scale in accordance to the actual processing cycles of your pods. So we're starting in the beginning stage of evaluation, but I'll be happy to share my experience with it. But it's just interesting. I want to point out that it's an interesting technology that fits very well for essentially a high-frequency trading system. All right, so I pretty much will wrap up here. We basically employed modular, basically migrated from modular to a parallel processing architecture. We really invest in the and take advantage of the preview environments to scale up our development effort. And then, as described in the previous, previously, we basically migrated from essentially a traditional data management architecture to a essentially distributed data architecture. And then we also automate a lot of our workflows through from our recruiting process to our CI/CD pipeline. All right, so I think that's the key takeaway that I want to emphasize here is that in scaling startups really involves that really investment in the people, strategy, technology, and tools. So I'd like to basically open the floor up for questions. Go ahead. Yes.
Yeah.
Hold on.
Yep.
Oh, yeah. Hello, watchers. You talked early on about review app environments and testing environments. I'm curious how you've been able to bring data sets that are obviously not production data to review environments that replicate or have similarities to production data, and to figure out and test edge cases that you might only find in production in these review environments.
Right. This is where it's similar to the way that we instrument the unit test. You basically will have to find the right appropriate subset of data that reflect the real deployment environment to your preview environment for testing. So there's an option that you can actually expose the preview application to the external world, where you obviously risk some of the security vulnerabilities for that the external facing application. But that's one way to test the actual new feature that you intend to merge.
Awesome. Thanks, Ellis. I'm glad that I share similar problems to you. Feels good.
Yeah. So that's the gentleman here.
So I guess I thought of this question when you were talking about the AI stuff, but also you have a lot of sort of little pieces of code and microservices that are all running. How do you think about kind of maintainability and code quality and technical debt?
Right. So that's really a consideration that the leaders have to take into account for, regardless of whether it's the code is generated from essentially the AI tool or not. Right? So what I personally employ is really the process of making sure that all the actual prioritization of our work has to allocate for send a good percentage of work to that dedicated for essentially the addressing technical debt and security vulnerabilities, especially. So it's really up to that leader some focus on whether they want to invest in addressing these quality issues and security vulnerabilities and technical debt.
With the auto-generated code and some of these other methods, do you have problems with maintainability, or is it just a black box and you throw it away and generate another one?
So we still certainly the way that actually we maintain quality for the generated code is basically they still go through that same pull request process. So we actually still have the team involved in reviewing the actual change before that generated code is actually integrated in our merchant domain. So again, we leverage the Copilot from GitHub simply as a way to provide some suggestions, and we actually even use ChatGPT as a way to compare to generate code as well, and then that code would then be integrated. Essentially, one of the team members would be responsible for taking that code and then as an owner for that pull request to basically then initiate pull request to get the actual review from the team before we actually merge that code. So again, it's not we still have to make sure that there's a human intervention in incorporating the AI generated code. Any questions? Oh, actually, any questions from online, by the way, in case it's
There was one question about the HR platform that you showed at the beginning,
Oh, okay.
and if you could maybe talk a bit about how you use that.
So you're referring to Aptical? Yeah. So it's a HR basically talent assessment tool that allows us to set up essentially a form that you can fill out with specific questions on from a cultural fit standpoint or technical. So basically, you can, for example, you can actually ask for candidates on the specific approaches to solving a programming language problem to how do you deal with certain situations in a team a project environment situation. So the responses are recorded and then basically be passed on to the hiring team for review. So, there's also other tools that allow for automated coding tests. You can actually allow for, you can either have it proctored at the same or be recorded, be able to then review offline as well. So. Yep. So, a question there. So, no.
Two quick questions. One is just the bots in your diagram. Are those in your high frequency trading diagram, the new architecture? Are the bots effectively the end users, or are they entities that anticipate end user requests? Like,
right. Good question. So for high frequency trading platforms these days, they're typically the orders are placed through market makers or brokerage firms instead of individuals, because the actual risks and tolerance ratios typically are not really attuned to individual investors at that. So the orders come in from essentially market makers or other trading partners, and then we actually take the market data in to basically drive the trading algorithm. So
okay, great. And then the other question, I think you answered it earlier, but maybe I didn't follow. When you went from the before to the after architecture, how would you describe the gains in efficiency? Like,
so we were able to achieve essentially the scale to allow for us to actually span to digital markets where we were able to do before, because we just couldn't able to keep up with the volume and the frequency of orders coming in. So basically there's the architecture here is a lot simpler than actually what it actually is, but there's actually risk management modules essentially that allows us to calculate profit and loss and make sure that we have enough funds to submit the order and so forth. So those therefore we basically have to essentially have a control component in place to not force us to basically take on certain new orders coming in. So that really is a limiting factor. So once we actually move to a new architecture, this allows us to now expand to new market exchanges. So there's it's no easy way to compare, so to speak, the performance one after another that way. So.
Understood. Thank you.
You're welcome.
If anybody has any unasked questions, great opportunity for networking. I want to make sure that folks who need to get to their next event or wherever they're going are able to do so. But I encourage those who do have questions, stick around. Ellis, I hope you'll be able to chit chat with people and have time to answer those. So thank you very much to Ellis.
Thank you. And I should say a big shout out to the programming team. Is what a fantastic event they've put together so far this week. Right, so.
Absolutely. And thank you guys for attending and for the amazing questions. For those who are sticking around the rest of the day, our keynote tonight is going to have Yvonne Howe, Secretary of Economic Development, and Boston Globe's Scott Kirshner right here. It's going to be 6 o'clock, Suffolk University. The next event in this room is going to be a little while. Next event's not till 3:45, Community-Powered Innovation, Embracing Open Source Development. There's no virtual component in that session, so if you're attending virtually, you may want to check the schedule, attend your next thing. For those who are looking for another session, just ask the volunteers. They can help you get where you're going. And really cool thing, check this out. If you go to that tabletop over there, you're going to see kind of like a sponsor salad. Not only do the sponsors help us do events like this, but they also offer really good perks for our attendees. Things like free co-working space, legal hours, partnerships with local restaurants. So there's actually a URL on the tabletop over there. Check it out. See what kind of perks you can get. And we'll see you guys later on at other sessions. Thanks very much.